Scientists from Nanyang Technological University have uncovered the structure of a particular pneumonia virus enzyme. And this could be the key to helping researchers design therapies for viruses that often lead to antibiotic-resistant bacterial infections.
And to help us understand more about this, we're joined in studio by lead scientist of the study, Dr. Julien Lescar from the NTU School of Biological Sciences. Dr. Lescar, thank you for joining us.
Thank you, Steve. Thank you, Gaina.
So why did you and your team decide on this particular structure and this particular enzyme?
So actually, about 12 years ago, my group determined the structure of dengue virus polymerase, which is a very important drug target as well. And we went on also to work on the Zika polymerase, which is related. So we had the experience of this type of enzymes. And you know that these viruses causing pneumonia are very important in terms of public health, with about 140,000 children dying every year of this disease. And in Singapore only, you have about 20% of the causes of death every year due to pneumonia. So it's second only to cancer. So this is why we were interested in contributing to giving some options to treat these viral infections. Yeah.
So, Dr. Lescar, I'm hearing this. It sounds a little bit scary. So we know that this enzyme can be found in two specific viruses that cause severe and, as you mentioned, they're life-threatening respiratory diseases. As you mentioned, then pneumonia as well as bronchitis. Question is, what role does this enzyme actually play and how does it do it?
Yes. So actually, you can think of these enzymes named polymerase are a kind of tiny little photocopy machines. So your genes, Glenda and Steve, and my genes as well, are made of DNA. The genes of this RNA virus, or these viruses, are made of RNA. So to be transmitted and replicated, they need to be copied by this tiny little photocopy machine, like 3D printers, so to speak. And one way to block the replication is actually to block the activity of this enzyme, so they can no longer replicate the viral RNA. And what we did is provide a mapping, a very precise image of these viruses. So now you know the target, you know how it looks like, so it's very much easier to design a specific molecule to block the activity of these enzymes.
And when you say block the activity, you mean the blocking of the photocopying, if you like?
Exactly. You can no longer run the photocopy machine, so the virus can no longer replicate. Yeah.
Okay, is this the first time that this sort of way of addressing it or this sort of treatment has been sort of explored?
Actually, no. You have a very successful story which has been done on a hepatitis C virus, which is another virus for which there was no vaccine. And there's a very successful drug which is now on the market, which is called sofosbuvir, which is precisely a polymerase inhibitor. Same type of enzyme. So there is examples of successful therapy using this. And now we are actively engaged. We have set up a startup company named Epitoire, and we are looking actually for people to help us to help us in these efforts to design some specific inhibitors targeting these viral enzymes. Yeah.
So how far along are you on this trajectory of yours?
Yeah, so we have made some progress, but we still need, of course, to a lot of work, and we are really looking into collaborations with clinicians and venture capitalists to help us in this endeavor. And so this effort has been jointly made with people from MIT, Pete Deedon, Rich on Fine, also a very talented team of people at NTU. And we benefit actually from a very good environment at NTU, where we have this Institute for Structural Biology, where we can really do a lot of work in this field. Yeah.
Okay, and are there other applications that this could also, well, the learnings from this be useful?
Yeah, I think so, because if you look, you must have heard about viruses which are kind of related, like a measles virus. There's an outbreak, for instance, in the South Pacific Islands. There is Ebola. Everybody has heard about Ebola, which is also a very serious health problem. And these viruses all have a similar type of photocopy machines. And you could think actually of developing inhibitors against this series of viruses using the same type of technology, structure-based discovery informed by a cryo-electron microscopy. And we have all the resources at NTU in Singapore to perform and do this work and do a good contribution to public health, a very important public health issue.
So what are we looking at in terms of, trying to stop this virus from photocopying each other, in in terms of, are we administering it? You know, how will it eventually look like in its end piece?
Okay, so you're really looking at here. You have, of course, the vaccine approach, which is the best, but not always practical. But here you're really looking at designing a small molecule with as little side effects as possible, which would basically stop the replication, and then eventually your immune system will take over to clear the virus. So that would be one way we envision to do that. Yeah.
All right. Well, thank you very much for coming in and speaking to us, and good luck for this. We look forward to this.
Thank
We've been
you.
speaking to Dr. Julian Leska from the NTU School of Biological Sciences.